Thank you for joining the Metaverse Standards Forum webinar on the state of 3D asset interoperability using USD and glTF. Our presenters today are Marc Petit from Epic Games, Patrick Cozzi from Cesium, Guido Quaroni from Adobe, Henrik Edström from Autodesk, Eric Haines from NVIDIA, Felix Herbst from Needle, and Alexey Medvedev from Meta. First, a couple of housekeeping items. If you have any questions during the presentation, please ask any using the Q&A feature located on your Zoom toolbar at the bottom of your screen. We are recording this webinar and we'll share the link to the recording later this week. At the end of the session, please complete a short survey form to help us better design future events. With that, I'll hand it over to Marc Petit from Building the Open Metaverse podcast and Epic Games. Marc?
Hello, everybody, and welcome to this webinar. My name is Marc. It's a pleasure to be here today. So in June 2022, 37 companies launched the Metaverse Standards Forum to align on open standards needed for an inclusive metaverse. Membership has since exploded to over 2,800, reflecting strong demand for cooperation. The forum fosters metaverse standards creation by crowdsourcing priorities, forming working groups, and coordinating industry requirements for standard bodies. It does not create standards itself. But with so many voices, organizing effective action is indeed challenging. The process begins by crowdsourcing topics from the diverse membership, and then members vote on priority domain, just like we did for identity or 3D assets. So the forum offers a very exciting venue for stakeholders to guide the future metaverse through community-driven transparency. But realizing its potential will require a lot of patience, a lot of compromise, and a lot of work. By mobilizing coordination, the forum aims to accelerate the critical standards needed for the open metaverse to flourish. And domain working groups are a key to the progress, and today we're happy to report on the progress of the 3D Interoperability Working Group. A quick overview of our charter. The 3D Asset Interoperability Working Groups aims to facilitate cooperation between industry, open source projects, and standards body to evolve 3D asset interoperability. Specifically, it seeks to improve interoperability between USD and glTF, which are considered foundational for representing virtual worlds. The group will gather requirements and use cases to help evolve standards. It will provide test assets and experimentation results to standard organizations, and it plans to build open source tools to infrastructure to enable asset interoperability like convergence between formats. While not a standard body ourselves, the working group will coordinate industry needs and provide technical inputs to assist standards organization. The goal is to accelerate the development of 3D asset interoperability standards who are critical for the open metaverse. And with that on, I'll pass it on to my co-host for the podcast, Patrick Cozzi.
Thanks, Marc. Hello, everybody. I am one of the co-chairs for the 3D Asset Interoperability using USD and glTF working group at the Metaverse Standards Forum. Marc did a great job introducing the history there. I also wanted to share that over the last year or so, our working group has hosted about 20 education sessions where we've brought folks to come in to talk about anything from material definitions to geometry representations. We've been recording those and making those available. So the link is here at the youtube.com/Metaverse Standards Forum /playlists. So please check them out. You know, part of our working group is almost like an ongoing conference around this topic of interoperability. And I think what you'll see today is USD and glTF go very well together, and there's a lot of positive energy and collaboration that's happening. In addition to the working group, Marc and I also co-host the Building Open Metaverse podcast, where pretty much every episode has some talk about open standards, interoperability, and collaboration. We bring on a lot of tech visionaries who's also built things. Most recently, we launched season 5 and episode 1. Steve May, the CTO of Pixar, and also the chair of the Alliance for OpenUSD, joined us. So please check out the podcast as well. For today's webinar, this is actually an encore and a little bit of an update from a Birds of a Feather session that we held just about 2 months ago at SIGGRAPH. And as a BOF, we had a room that was of decent size, but not nearly big enough for how many people were interested in this topic. So a lot of folks on Twitter and at the conference told us like, hey, get a bigger room next year, which we hope to do. But we also just to, we don't want to wait till next year. So we want to share, the latest here. So we're doing this webinar. Okay, so Jeff did go through the presenters, but I also wanted to share that the presenters here that are talking today, they bring many different perspectives. Some have been deep in the specification and the schemas. Some have been deep building tools. Some have been building end user applications. So we're going to see a breadth across USD and glTF and materials and implementations. We're going to get a sense of what is the state of interoperability here, and where might we go. And we're looking forward to the Q&A at the end because everyone on this call can have a big input. So with that said, it's going to go over to Guido.
Good morning. My name is Guido Quaroni. I'm a Senior Director of Engineering for 3D and Immersive at Adobe. Today I'm going to talk about interoperability between USD and glTF. So when we talk about 3D assets, we want to make a distinction between authoring and delivery. So the authoring phase, for describing the asset, we need a rich set of schemas, and we want to be able to aggregate assets when we assemble pieces from multiple sources, and then enable multi-user collaboration. So the environment is definitely rich to be able to create various kind of assets. And then when it comes the time to deliver the asset, for example, to web portals, we generally want to use a limited set of schemas, so it's much more easy to understand the assets on the various platforms, especially the web. Also, the format used is generally tailored for single asset. Like in the most cases, one of the most common one is configurators on the websites. And also we want to have a small footprint and for transmissions, so that the tendency is to compact the data, have representation that maybe may compromise a bit on quality, but really gives you a much less file size. And finally, we have runtimes, and those are the system capable of actually playing and displaying and providing the experience of these assets that are arriving through delivery through the web. And those runtimes are multi-surface, obviously the real time, and also they support, in some cases, animation and simulation. There's many file formats used out there for representing 3D assets. Those are 4 of the most common one, and I would say OBJ and FBX. OBJ is actually used for transport. FBX was kind of used a little bit of both, but also for transport as well. And those are kind of the formats being used for many, many years. And the most newest ones, glTF and USD, and again, glTF used for transport, and USD kind of used for both. So if you look at the capabilities, USD is probably the richest, one of the richest one, but exactly because it's used for authoring. It also can be used for transport as well through USDC representation. But one of the big downside right now that except for the Apple platform on Safari, USD is not currently a web-friendly file format. So let's talk a little bit about glTF and USD in more details about what are those differences, the pros and the cons, and why you want to use one versus the other. So first of all, let's talk about the principle. So glTF, the design principles is compact file size. Again, the representation tried to be as efficient as possible, and because it's considered, again, final step of the presentation, kind of a leaf nodes in the scenes. It also is capable of being displayed in many different runtimes. It actually doesn't require a custom runtime, so that's why we call it like a runtime independence. This in particular case is quite easy to have a way to represent glTF on different web browser and different web runtimes. It has a complete 3D scene representation, so you can have a complete asset in geometry and material, and including animation. And it also is extensible over time. You can have revision and extension to the schemas. And again, this by design is easy to deploy on multiple platforms, desktop, mobile, and web. When it comes to USD instead, It was designed fundamentally for an interchange, it's an interchange system, really designed to work between authoring application. And so because of that, it really, the idea is to retain as much data as possible. Also has a capability to assemble and organize multiple assets. This is part of again, the authoring phase. You want to bring pieces, geometry, material for multiple places and assemble them together. Also has a non-destructive editing capability in a single scene graph. And this is the mechanism that allows to do override and make changes without necessarily be in a non-destructive way, because it gives you the ability of compose and have different layers of opinions. And again, it's designed for collaboration using scene composition. So the main purpose, main goal initially for USD was to be able to support multiple departments creating assets from modeling, shading, camera, layout, composition, and animation, etc. Let's talk a little bit about the basic concept about between the two systems, so that you get a better idea how they are structured. And then glTF glTF file is defined what we call an asset for an individual file, and inside this asset there may be multiple representation of these assets, and they call it scenes. That's why there are n scenes possible inside the file. And then inside the scenes, there are a bunch of nodes. There's a scene is composed by a variety of nodes, for example, geometry nodes. It uses a YAP coordinate frame that is more common in the games industry and media entertainment. The units are meters, and the rotation are radians. When it comes to USD, a USD file, a USD scene is called a stage. And then at the stage level, you can have multiple root primitives. And within the root primitives, you have, within a stage, you can have then scene graph, like a bunch of nodes. And those nodes connected together are called prims. For example, a mesh. USD support YAP and ZAP. This is to support some studios, probably very few of them, they still use a ZAP coordinate frame, but also some architectural and CAD software that actually still rely on, prefer actually to rely on the ZAP coordinate system. And the units are configurable. And there is a particular system defined into the scene called meters per unit. So then you can just start with meters, but also you can use other units by this multiplier. And finally, the rotation are in degrees. Let's talk a bit about the file format between glTF and USD. glTF has a support versioning. It is being encoded as a text and binary, and depending on the different use cases. It can also have embeddable resources. So this means that you can have a file that contains geometry as in the JSON representation, but also you can embed textures. The media types supported are PNG and JPEG media types. And the representation is a JSON format. So, and this makes a glTF extremely easy to be adopted on many platforms, in particular on the web, because of the JSON format being adopted, being used. USD also support versioning. It has also a text and binary representation. USD is also known as the USDA ASCII and USDC as the binary, and also has a USDZ that is like an embedded version, and that is called again USDZ, where you have in a package, and the way it's called Z at the end is a Z because it's a zip file. It's an uncompressed zip file where you will find USD files, and then you will find other assets like, for example, textures. PNG and JPEG are the media types supported. I believe there's been conversation about adding EXR support as part of USDZ. Not sure exactly where it is into that process, but this is a possible new addition. And also, it can have, it has a custom encoding. So that requires a dedicated custom parser. It is open source as part of USD, but it still is it's a custom software to read and write the files. The transforms, those are really important when we describe scenes in glTF. Any node can have a transform. The matrix, can be a 4x4 matrix in the more general case, or there is a specific order of operation, translate, rotate, and scale is also allowed instead. And the order is enforced, so it is very clear. And this is part of when we talked about the easy to adopt, easy to deploy simplicity. Obviously, accepting some of the limitation is the order of operation is enforced. And so, for example, this is a pretty simple and basic operation order that, again, is simple to understand and to execute, but it may not provide certain capability that may be more, again, needed, especially when you are in authoring phase or more complex assets. Obviously, the 4x4 matrix has to be decomposable, so no shears, no crazy stuff in there, because then you want to go back possibly to the translate, rotate, and scale. And the matrix is not animatable versus the 3 individual transform component, those are actually animatable. UST, it can have prim, certain prim can have transform, not all of them. Some primitive are just meant to be scopes that are grouping purposes, and others instead have transform. But I would say the vast majority of the primitive in a UST file also have a transform. The transform order is arbitrary, and this is taken from other formats like Alembic, where you can actually compose different operation order. You can have the 4x4 matrix, but also you can compose different, or in different order, translate, scale, and rotate. And this can be quite useful when you want to fully represent a transformation stack of use in some authoring application, where you have multiple, even scale and even rotate and scale pivots, and you want to all combine it together. And this is how you encode them into an arbitrary list of operations. And all the X-form components are animatable. When it comes to geometry, in glTF, and these can have a mesh. Mesh can also have primitive data. And a glTF currently today is really focused on representing mesh data structure, triangles, meshes. And so it really greatly simplify the kind of geometry that you can represent, but for that purpose was really meant to be for easy integration, fast integration, and display. Primitives are, the data. This is where it really comes one of the big difference. The data in the glTF file, it's really organized to be extremely efficient, to be transferred to the GPU. It was really meant to be really for final display. So the data itself, the primitives and the data itself has a specific organization that make it GPU friendly. Primitives have different attributes like position, for example, and also they can have a material. If you wanted to do per first material assignment, you need to actually create and construct and different for each material you need to have like a primitive. And then you can have index and non-index attributes, so that you can have more efficiency, especially when you have attributes that are they're actually sparse on a mesh, and so that's why you use kind of indexing. When it comes to USD, there is more geometry types. For example, USD supports obviously polygonal mesh, arbitrary polygonal mesh, also not just triangle meshes. Supports subdivision surface, but also support NURBS surfaces, and those can be quite useful when representing an asset and built through CAD systems. For example, there is a prim type called USD geomesh that defines the mesh primitive, and the mesh can have attributes and primitive variables. So individual values on the mesh, but also per point, per face, per vertex, face vertex. There's all sorts of different kind of representation, but on each mesh you can have primitive variable like color, UVs, vectors, normals, etc. Also, the mesh primitive is used also to describe a subdivision surface. There is a few additional tags and attributes that you can attach when a mesh is turned into a subdivision surface, like creases definition, but it's fundamentally the same. And the schema, it's very general. So it's described, the data is described for readability and for authoring and to describe, this variety of it. And so it was not as tailored for a GPU representation. And this is probably one of the big difference when it comes also to efficiency in terms of loading and passing the data into the GPU. Also, the USD can have, again, the number of primitive variables can be arbitrary number. And then there are, again, like I said, multiple interpolation types of these variables, and also have indexed and non-indexed primitive variables. Let's talk about shading. This is a quite important aspect. And so in glTF, there is a well-defined material definition. It's there's a specific material type as a very well-defined spec, and this is really meant to be, again, to make it extremely easy to map this material, especially when it comes to renderers running on the web, and also to make sure that you have a pretty high level of consistency between multiple glTF files. They actually adopt a modern PBR material, and also can be extensible. There's been a revision and extension to this material to add new capability. USD, on the other hand, it supports a much more general shading system. You can have complex material and pattern graphs. You have what is called primitives. You can build a shading graph, and the primitive there is a basic PBR material used for preview, but technically you can define a node that represents an arbitrarily complex shader or an arbitrarily complex shading graphs. So that gives you a lot of flexibility in terms of when you describe your materials. On the other hand, it may be less the case where you're using strictly the USD preview surface meant for previewing assets. Aside from that, if you use any kind of arbitrary shading network, it becomes quite difficult to ensure that those graphs are rendered the same across multiple platforms. This is where standards like MaterialX will really come to help, where you can have describe as a general material system as a shading graph, but actually adopting specific standards and protocols for the actual nodes that you're using in that graph to be standardized. So what are kind of the high-level observation that we can conclude here as part of these two systems? At the authoring level, we have, for glTF, it kind of have a limited set of primitive and a fixed material specification, so it kind of has some constraint there. But when it comes to delivery, requires a much simpler runtime requirement and is really optimized for real-time rendering and interactivity. USD, on the other hand, at the authoring level, offers advanced feature like composition. It gives you different kind of a flexible set of primitives, and also you can build complex shading materials through material graphs. But on the when it comes to delivery, you need to bring a complex runtime system, the USD library, that it's a fairly large runtime, FurG library. At this point, it's kind of available on natively is available on many platforms. But again, when it comes to web and converting to a WebAssembly, there's been some early exploration there, but it's a fairly large WebAssembly system. And again, the data layout by definition is not necessarily as GPU friendly, so there is translation involved when you want to actually move the data for rendering on the GPU. What about interchange and lossless or lossy interchange between the two? When you move, when you're working in an environment and doing authoring, and ultimately you want to convert to glTF, imagine that the USD can represent the vast majority of the needs of an authoring environment. I would say probably half of the features are potentially lost into translation. Now, what a lot of processes, we call it baking. You can actually simplify your authoring environment and removing some of the capability as you export to glTF. So this number may vary, but again, there's many concepts in USD where, in a way, baking itself, like for example, tessellating an earth surface, you still have a representation of that primitive, but it's not exactly the same, and you lost some fidelity. On the other hand, be able to bring glTF into USD, you have a much higher chance to retain much of the features. And so this is where, if you are using USD in your authoring environment and you want to actually bring in glTF files, in that case, there is a good chance that the vast majority of the features present in the glTF will be retained into your USD scene graph. When we think about having a unified system, and this would be maybe a idealistic system to consider, imagine you have many applications out there. Those are all great authoring applications. And each application relies on their own document, application documents, so they have kind of their own native file format. But if this application, we're able to bring a really high level of interop with USD, with the, be able to not lose too much, let's say, when they go back and forth using USD. Definitely, there's always going to be some loss compared to your native document. But assuming that you have enough data type and primitive type, if USD was your kind of a main interop system at the authoring stage between applications, you could possibly envision a way to really have a unified system to bake USD, obviously much simpler to turn them into a USDZ. There is definitely some limitation and some baking involved, but a lot of the data and the primitives are the same, but also convert to glTF. And once you have these two delivery systems, then you can actually bring this data to multiple surfaces that can be mobile, immersive, or web, and etc. So that's kind of a conclude my kind of a quick explanation about the two systems. They're great systems, and there's a lot of work, going on these days to make sure that those two systems can interop with each other, because there's actually great value, and they really serve different purpose, and so that's why an ecosystem built around them, it can be quite beneficial. Thank you very much for your time. Bye.
Thanks, Guido. So my name is Henrik, and I will talk about the PBR material interoperability, which is one of the areas that we decided to tackle early on as part of the 3D Asset Interoperability Working Group. So I will touch a bit on MaterialX, USD, and glTF here, and the material aspects of those. So as you saw from Guido's overview here, for the authoring workflows in particular, so not necessarily for the final delivery workflows, but for authoring workflows, we see a combination of USD and MaterialX as the common language here to achieve consistent interop between all these different tools, potentially from many different vendors. And as Guido mentioned, the material aspects of USD are kind of open-ended. You can express any sort of a material shading graph in there, but it's not necessarily something that is specified in a way that is portable between different tools. So that's where MaterialX comes in, and you have a well-defined way of expressing the material graph. So I'll give a quick overview of MaterialX. Jonathan Stone had an education session on MaterialX a while back, so you can find that in the link that Patrick shared earlier on all the prior recordings of share outs. So we had one on MaterialX there, but it's really an open standard for representing rich materials, and it's it's platform independent way of describing the materials and exchange them across not only renderers but also authoring applications. And I think that's an important aspect that is different from some other means of interops. It's not just about making the material renderable in a consistent way across multiple targets. You also want to be able to pass the material between different authoring tools and allow the tools to work in their native editing environment, usually through some sort of node graph editor. So basically you have three main parts in MaterialX. One is the pattern graphs, which is basically a set of image and math nodes that drives the input channels of your material model. So those could be color, roughness, IOR, and so on. And then you have a PBR shading graph, which is another node graph that expresses your material model or PBR shading model. So that could be something like USD previous surface or a standard surface, Adobe standard material, the glTF PBR model, and also the open PBR shading model. I'll talk a bit more about that one in a minute. And then, of course, it can express any other PBR model as well. And then you also have a shade generation library as part of MaterialX, which allows you to take the pattern graph and the PBR shading graph and generate executable shader code in your language of choice to make it easy to adopt into your renderer. So out of the box, we have support for GLSL, OSL, MDL, and metal shading language, but it's very extensible and easy to add other targets as well. This is very high level overview here on MaterialX, but yeah, please see the prior education session for more details on MaterialX. So at SIGGRAPH, we announced something called OpenPBR. So this is a material specification that has been a collaboration between Adobe and Autodesk, and basically combining the Adobe standard material and Autodesk standard surface into one unified shading model here. So it's not a completely new shading model, it's a incremental evolution of these two prior models. And another aspect that is important here is that this new model is now governed under ASWF Academy Software Foundation as a sub-project to MaterialX. So it's under neutral governance and allows anyone to come and participate in the evolution of this model. So again, of course, this is not a static model. It will continue to evolve as material research progresses and so on. So I'll just show a few quick renderings here of OpenPBR. On the left-hand side, we have the Arnold render inside of Maya, and on the right-hand side, we have Adobe's proprietary renderer. So this is still early work, but we're already pretty far along in making the materials consistent between different renderers. So we did have an education session on OpenPBR as well last month. So the full recording of that one is available with much more details around OpenPBR. So please check that out if you want to know more about OpenPBR. So one thing I want to touch on for interoperability of 3D assets, we have a pretty strong consensus that an Uber shader model is highly preferred. There are other ways. You have very flexible shading languages where you can express any sort of shading model, but having an Uber shader is beneficial from several different perspectives. The first one, and maybe the most important one, is that it's very artist friendly, and it's simple and intuitive for artists to work with an Uber shader model compared to maybe writing shaders in a more flexible shading language. And in practice, Uber shaders can accurately represent the vast majority of materials that you would need, whether that is in visual effects, feature animation, or architecture and design visualization, or e-commerce, etc. So there are, of course, some exceptions, some esoteric materials that would require, specialized shading model. But in practice, those exceptions are relatively few. It also makes it quite easy to make materials portable from high-end offline rendering to more constrained real-time engines. As you have the full conceptual understanding of the shading model, you can make informed simplifications and good trade-offs between accuracy and performance, which is much more challenging if you just have kind of an arbitrary shader. It's much harder to reason about. And it also is easy to map between these different shading models. If you have an Uber shader, it's easy to map back and forth between other common material models, such as glTF PBR, which is, of course, also an Uber shader. So lastly, I want to talk about PBR in glTF. We've applied the same principles as all the other popular PBR Uber shaders, but taking a more incremental approach through extension. So we started with a very basic metal roughness workflow as part of glTF 2.0, and then we have since then added new extensions in different phases. So the first phase, we had a clear coat, sheen, transmission, then specular, index of refraction, volume, and the last three ones that has been finalized are emissive strength, iridescence, and anisotropy. And since we are using an Uber shader here as well for glTF, why didn't we just adopt one of the prior ones? But there were several reasons for that. There was no existing PBR model that was widely supported by engines or tools, and specifically around real-time implementations. They were not necessarily mature across both game engines and web engines. So we decided on a more incremental approach, as I just described, through these extensions, with a focus on extensions that would be practical to implement in real-time engines today. And we kind of prioritize the business value, or the benefit of having a particular extension in combination with how mature it was, what was the consensus on how to parameterize it and how to implement it in various different engines. So that's why we started with clear code that was high value and simple to implement and getting consensus on, whereas some of the more recent ones were more complex and took longer to finalize. And we still have a few things in the backlog, such as subsurface scattering. But we did use all these existing PBR models as a basis for the glTF PBR extensions. So some of the ones that we looked at was we standard material or a standard surface, Blender principled, Dassault enterprise, and USD preview service. So the glTF PBR extensions it's easy to convert from these other popular models into glTF PBR and vice versa. So another topic that has come up especially in the last year is how can we possibly align more between glTF PBR and MaterialX? So since last year, we have a full MaterialX shading node graph that expresses the full glTF PBR shading model. And we recently started exploring the possibility of using MaterialX as a procedural graph for glTF and driving inputs to the existing PBR model. So that, in addition to getting more flexibility in creating procedural materials, it could also allow us to have higher detailed textures with a smaller footprint, which fits well with the purpose of glTF being a efficient transmission format. In many cases, just having very large bitmaps is it wastes a lot of memory, and you can capture just the same or even more detail through a simple procedural graph instead. And this would remain compatible with the existing glTF PBR models. At this first stage, we're not thinking about adopting the shading graph aspects of MaterialX. And for an engine that doesn't support this full procedural graph, we can always have a fallback to baked textures. So just in summary, we do have most of the building blocks needed for PBR material interop between USD and glTF. We've started to explore some aspects of MaterialX inside of glTF. And I think one opportunity we have now is to increase the alignment between OpenPBR and glTF PBR, in particular when it comes to real-time workflows, because we've really spent a lot of time there in the glTF working group to make all the glTF PBR extensions very practical for real-time engines to implement. So here are a couple of links to more information on all of what I presented here. And I particularly recommend the prior education sessions that we had on both MaterialX and OpenPBR. So that was it from my side. Thank you.
All right. Eric Haines here, just trying to queue it up. Let's see if this is the right one. All right, so I'm going to talk about USD and glTF more from a user's perspective. Guido and Henrik have done a great job, honestly, of going through all the similarities and differences. And I'm going to give more of a view of just having to be sort of in the trenches and trying to go from one to the other, and what the advantages are of each. So let's see, now can I get this going? There we go. So if you find you've listened too much, you can now try to scan this QR code or type in that URL, and you'll see a little simple project that I added to the USD working group assets, which is just some sort of Minecrafty blocks with some sort of fancy physically based materials on them. And the point here is, well, there's sort of 2 points. One is that, wow, this is really cool. This, this actually works on my iPhone. So, that's kind of astounding, actually. But it also will show there's basically two major minor rendering flaws in the implementation on the iPhone. And it just shows that there's different viewers have different strengths and weaknesses. Some are very USD compliant, some are very glTF compliant, others are a little weaker, and so on. And so it's important for you to kind of know, as a user or as an implementer or whatever, that sort of what the strong viewers are, what's the kind of ground truth viewers, and so on, and to try to know what the limitations are. Like if you really are targeting the iPhone, you really need to know the iPhone viewers' limitations, for example. So this is sort of the think to yourself, quiz to yourself, which way is up? Guido actually talked about this a bit, and how each spec sort of works on this question. So do you prefer Y is up or Z is up? Well, if you go Y is up, you probably like movies. It's very much a film world kind of a thing, as Y is up. Or you like video games, like the Minecraft world is Y is up. And Moana, that's a big data set that is a plus Y kind of a set. And for glTF and USD, that's the default. Z is up is much more common if you're in sort of the computer-aided building things kind of world, like 2D architectural prints. Well, if you think of the third dimension, Z is up. 3D printers, GIS, and so on and so forth. The point is here is that glTF, there's no real way to choose this direction. For USD, they have these idea of a little metadata header that kind of goes at the top of the file, and you can pick something like up axis equals Z. And so again, you have to kind of watch it with that, that metadata may or may not be implemented by the viewer that you're looking at or that you're aiming for. So you sort of want to test. There's another fight that you can cause between graphics nerds if you sort of say, hey, I use left-handed, and someone else say, oh, I use right-handed, and then, the religious war commences. Well, with glTF and USD, they both use right-handed coordinate systems. And the funny bit is that, all of these apps sort of have different Y-ups and Z-ups as their natural, and left-handed and right-handed, as you can see in this cool little thing by someone else. But anyway, this frail Homer. Anyway, the gist is it doesn't really matter because it's just some transforms, but it's again sort of just good to be aware of differences. So what's your preferred measure of distance? It might be millimeters, centimeters, meters, kilometers. I have a biologist friend who says, micrometers, because he's looking at cell stuff, or he's looking at a smaller scale and stuff. Whatever the case, basically, if it's glTF, you can have any, it's sort of like the Model T Ford. You can have any color you want as long as it's black. It's basically meters. That's all you have is glTF. And for USD, you have this metadata thing you can set of meters per unit. By default, it actually is set for centimeters. And I have found that you can change this number. I mean, you can use this effectively in some viewers, but it can be touchy. Like, everything might not adjust. Like the camera, for example, your camera clip range might not adjust depending if you change this number. So things might get clipped by the near plane or whatever. So anyway, this is one that I personally kind of keep away from this and just kind of internally change the units using node transforms and whatnot. Another one is, okay, how do you set your field of view? What does your camera see? There's sort of field of view, there's film back and focal length, and then there's answer C, which is I use field of view, and what in the world is film back? And this is indeed a poll I gave about a year and a half ago, And indeed, me and many other people didn't know what film back is. That's a film term, and one that you would know if you're in the film world, but the rest of us don't. But the good news is this doesn't really matter too much. It's easy to convert from one to the other. It's not very, nothing deep there. The only thing you might want to be sort of aware of is sort of vertical field of view versus horizontal field of view, and keeping that aspect ratio and so on. So if you're converting one to the other, you might have to think about that a little bit. But basically, this one isn't so important. Next one, how about lights? Do you specify lights by intensity? Lumens, candelas, lux, nits, that's a physically based kind of a thing. Or unitless, so you just say it's 5, and if you want it brighter, you turn it to 7. Well, basically, any of these are kind of fine in a certain way. 99% of the time, we're just not caring so much. You would just want to make the lights brighter or darker. It's all sort of relative. But the word intensity, just so you know, doesn't really mean much in the world of lighting. Like it's sort of just a term saying brightness or strength or whatever, but it's not really a physical unit. And glTF and USD have this kind of idea of intensity, this sort of non-physical thing. This whole units, lumens rather, candelas and so on, that is serious in the sense that you can really get truly physically based. Like you can take a actual physical description of something, you can merge CG, computer graphics and live action. But like, for example, glTF specifies nits for surface emission. So anyway, but that's sort of a loose area right now, that it's sort of undergoing definition in some ways. So be a little bit aware that you might not find everything you want to do right now with that. And unit list, I actually kind of appreciate it, nothing saying like brightness or intensity, because it's just honest. It says, hey, it's some number, you can make it bigger, you can make it smaller. And so, for example, you'll find in USD preview surfaces emissive color, that's essentially unitless. I'm finding with most applications using some range from 1 to 10 is going to give you something reasonable, but again, your mileage may vary. Don't be me. I say maybe don't be me, but probably don't be me. I actually sort of went through this whole exercise of looking at the equations. There's this great document, Fizzlight, which I'll talk about in a second, which talks about how Weta actually deals with light and all the equations associated with, given this light and given this amount of lux hitting a surface, and given this material, the standard material, and given these exposure values, what do you actually get at a pixel? And it works, magic, equations actually work. But you hopefully don't need this kind of level of detail, but maybe you do if you're really working on serious film work where you're combining stuff. And like I say, if you want to know where pixels come from, this Fizzlight documentation is really a great resource. These notes, by the way, will be available online at the end. I'll show a link to those, so you don't have to be photographing the screen or something, or taking screenshots. Anyway, this stuff works. Let's see. So, okay, let's get back to our little test scene. It turns out this test scene on the iPhone, and I'm not picking it on the iPhone, I think it's actually incredibly awesome that I can pull a USD file and for the most part see it on my iPhone. But one catch is that they don't have double-sided as an attribute that's actually implemented in this viewer on the iPhone. So this is the kind of thing you kind of have to watch for. So there was a stem for the sunflower, and it was really just a flat polygon, like a little cutout. And it was just made one-sided, and then I put an attribute on it in USD saying make it double-sided. But this viewer doesn't happen to implement that double-sided attribute. So it's, again, something to be aware of, that if you're using double-sided, watch your viewer. Another one is that the other bug that you might notice if you had really good eyes is that the lighting didn't really match how the bump maps worked. Like, so the normal map applied to this this sort of pebbly surface. If you look closely, you can kind of see that it's getting highlights as if it was lit from underneath. And it's not that there's really a light underneath, it's that there's a light above, but they they just hadn't implemented the way that normal maps can be applied in USD. In USD, there's a lot of control you can have. You can control bias and scale of the X and Y and Z components. So you can do all kinds of interesting tricks and so on. You can convert from different formats. And it turns out DirectX and OpenGL, they do it different. So to fix this, you can actually fix this in USD. In glTF, you have to actually mess with the normal map. OpenGL style is kind of what's supported. So again, just a mismatch there that you might run into if you are trying to take things from, say, a video game that was sort of authored with a DirectX in mind. And so the trick with all this stuff is that, you know, we can make tests and share them with each other. And I highly encourage you to do this. It's not hard, you know, you can actually get involved in making, you know, test models for USD or glTF. And so I contributed this model to the ASWF's USD working groups, assets, GitHub repo. And basically it just says, here's 3 different mappings, and they should all look the same if your USD viewer is fully compliant with it does this whole bias and scale thing. So anyway, this kind of thing really helps us. And so towards that end, there's lots of test models out there. I'll get to that in a second. I'm not going to talk about the materials. Henrik did a great job on that. Basically, things are mostly there, but you know, there's a little loose ends, and they're getting polished. Basically, they're getting, you know, defined, and people are aware of the problem. So, you know, upwards and onwards, things are getting better. So there's, you know, lots of sort of testing and educational resources out there. glTF I kind of think of as the big brother to USD as far as testing goes. There's a lot of test models out there, a lot of things you can test against, and so, you know, being able to convert from one to the other is a very nice thing. There are a bunch of converters out there. There's other resources, like I'll put in my little plug for NVIDIA here, is that part of NVIDIA Omniverse is that they have a precompiled USD view for you. You know, you yourself can actually go to the sort of open source, open USD, and find the USD view and compile it yourself, but it's not a lot of fun. And there's a bunch of other tools, like USD Checker is really handy for throwing at files, and it'll tell you of things you're doing wrong. And anyway, that's sort of, there's other cool things, like I say here, there's a USD asset validator inside Omniverse and so on. So these are all good things to give a look to. And this is going to be my kind of lead into Felix's talk, who's next, which is, this is a really nice sort of set of files. And it's just really nice is that you can just go to this website, look at files, download glTF versions, USD versions, see them in the browser, and quickly sort of have, you know, sort of a ground truth that you can compare to and so on. So it's really nice to see more and more sort of testing tools coming out. And that's really about it. You know, test. I have 2 sort of very similar bit.ly shortened URLs here, and you know, write one down, and it'll point you at the other one. Basically, there's the, you know, glTF USD one and the USD glTF one, and basically these are, you know, where you can find this talk and where you can find a bunch of resources that I've collected, and that's about it for me. I'm handing it over to Felix.
Thank you, Eric. So this is where I'm going to start, and I'm going to talk about a somewhat more like practical look at glTF and USD and converting between them, looking from various perspectives. Maybe a word about me. I'm responsible for interoperability and R&D at Needle for bringing stuff to the web, but I also have a lot of experience at prefrontal cortex from kind of an agency perspective on creating stuff and making things work. And as part of both of these, I've been touching upon a lot of the open source projects that kind of underpin glTF and underpin USD today, with kind of a mission to make things work for regular users that don't have as much exposure to kind of all the technicalities. And kind of as a practical example, with Needle Engine, you can do things like you author something in Unity that has like materials, animations, interactions, audio. You bring it to the web. We're using glTF for that, but mostly intransparent to the user. Like, you don't need to know about the features there. We show it on the web, and we also do a runtime conversion to USDZ, because that's like the only way nowadays to have nice augmented reality on iOS and visionOS and all these devices. And the fun part is keeping as much as possible throughout this entire chain intact. And the additional challenge is that in this case, nobody is clicking on a export glTF or export USD button. We're aiming to make this as seamless as possible. And that also means, of course, running into lots of small and large problems. And that doesn't only apply to like toys like this little musical instrument, but also to things like product configurators with like multiple variants and all that kind of stuff, where especially rendering fidelity and getting out what you put in at the front of the pipeline is super important. And in a nutshell, a lot of what this looks like is that you come from some arbitrary application with like a needle add-on in it. You go to glTF and then to a browser, and USD comes into the mix either at the very beginning or at the very end of this process. Like in the beginning, because most of these softwares by now allow you to choose freely what are your source assets and materials, which format are you working in. And in the end, because we kind of opted for going the entire route in glTF, and in the end, turning things back to USD for specific devices. And in a nutshell, it looks like this. You have round trips everywhere, which also means dealing with a lot of these conversion issues that were mentioned through the varying talks, and things like getting materials through the entire pipeline as much untouched as possible. And like this is something that works today. Like a lot of things can just seamlessly flow between these applications with a lot of like fixes and work put into all these various open source projects that kind of form the centers here. And yeah, in a nutshell, what you always have to think about, or what we especially have to think about, since we want to make this as easy as possible for users, is there's subsets of features working in one or the other software. Like typically, for both glTF and USD, you have to look at what features from them are imported into your application, into its usually internal data model that is different to either glTF and USD, and what can be exported again in the end and is yet again a subset of something. And there's no full overlap between any of those, which is why I can only encourage people, if you find something that doesn't work, please report bugs, because the people working on this are usually very, very happy when they see specific cases of stuff working or not working. There's a particular fun thing, which is some applications have started doing bypasses here, where basically they say, oh, you import USD with some features our application can't do. We're just going to keep it around in case you want to export it again. And this may be nice for some workflows, but in general use, this makes more problems than it helps, because it kind of covers up that a specific application can't deal with some data. And so this is particularly nasty to work with when understanding what works and what not. Like I want to say a few words about like an application saying they support a specific format, like, hey, your application says we support glTF now. Then I would always encourage you to figure out, does support here mean importing or exporting or both? And what particular things are actually supported for importing materials, exporting, like what actually flows into the application and out of it. And for glTF, that's mostly it, like figuring out which extensions are supported, what matches the internal data model, and so on. For USD, the same is true, but there's additionally a couple more things to be aware of, like which actual USD version is it that is supported, because there's like regular new USD version. glTF is pretty much frozen as a spec. With USD, things are more changing over time. And so also you need to take a look at like which type of materials does it support. Like there's at least 3 different ways how materials can work in USD. And then some applications support multiple of those, some only support one specific one, and so on. And which file types and which schemas and so on. So there's more to keep in mind. And in terms of practical use, I think what this means for us at least is as we heard through the various presentations now, USD from the scope perspective is the much bigger feature set. Like it has composition, it has all these kinds of additional things that you can do with it. So the theoretical feature set is very, very large and much larger in scope than what glTF does. But in practical terms, there's a lot of features from USD that are not very practical today. If your goal is actually seeing the same thing across multiple applications, like that's a little bit of a different goal than just moving data across. It's explicitly, I want to see the same thing. Like I want materials to match, I want meshes to match, I want appearances to match. And I think glTF is quite a bit further ahead. There's also some things in glTF that like don't flow nicely, but are in the spec, like UV rotations or color blend shapes and some other exotic features. But the list for USD is much longer, where you will usually find that an application supports like a random subset of these USD features and doesn't support the others. And we've coined this internally as kind of the safe subset, like something that is actually well supported between applications. And I think it's worth noting that the safe subsets of glTF and USD are also not fully overlapping. Like we already heard about like double-sided and transparency and normals and so on, that just work a little bit different in them and aren't actually like there's not a one-to-one match here. And like the usual answer from like the USD side of things is, please use our libraries and our tool chains, because then everything works and everything is supported. But in practical terms, that's not viable for a lot of engines and runtimes and systems that already have their own internal data model and need to convert in one way or another. So which brings us to converting. And from my experience, what works best there is if you go through an application that has a strong internal data model on its own. Like there's a couple of converters that are kind of standalone applications, but these usually don't work as well because they do everything at the same time. Like they import something and export something and try to move things across. And with a strong like internal model, applications can separate the concerns between these. Like someone can do the import side, someone can do the export side, and really make sure things flow nicely. And some examples of ones that have these internal data models that are like good and bigger than what glTF and USD do are like Blender, Unity, or 3JS. And these happen to be the ones that I worked with the most. And you have to differentiate there also a little bit. Like Blender is kind of okay-ish for both of these things in version 3.6, which is the current one. It will likely get much better in 4.x due to the work that NVIDIA is doing there. Unity needs third-party plugins for both of these formats, and then you can get lucky with your specific workflows and pipelines for things just working. And 3JS, the one that I spend the most time in actually fixing stuff and making sure things work, I would say it's pretty good today, because that's kind of the underpinning of this whole pipeline of what we're doing at Needle. And just to show like a little bit of how that works, it means that both from glTF and USD, you go into the internal data model of 3JS, like scene graph, similar to how other systems have that. You can load glTF, you can bring custom data along, and you can export both glTF and USD in the end with like varying degrees of completeness on what survives through this chain. Basically, for example, for materials, we can go pretty seamlessly from the glTF PBR model to mesh physical material in 3JS to use the preview surface on the other end, and can even do this through the ability to attach like custom extensions and stuff here for interactivity, custom data that needs to flow from one end to each other, like keeping interactive components and audio and all that stuff actually surviving from some authoring application on one end all the way to runtime conversion to USD for iOS on the other end. So, and to what Eric just showed, a lot of what we've been building is in the ecosystem around this to make sure that data can flow nicely around. The Asset Explorer is one of those, kind of showing for many GLTF assets as kind of a ground truth. How do they look when I actually convert them to USD in various of these applications? And there's like 3JS conversions, there's Blender conversions, there's Omniverse conversions that also NVIDIA has helped with. There's a USD viewer that we're maintaining that kind of shows, based on the work from Autodesk, shows the state of the art of like viewing USD on the web using the WebAssembly version of USD plus a Hydra delegate that converts data into 3JS model, where you can actually download a pretty well converted GLTF file in the end. And we have our own GLTF viewer on the web, where soon you'll be able to download converted USDZ files. So this kind of covers what you can do on the web, and as some examples for like round trips, including interactivity and audio and so on. We also have an AR showcase for kind of multiple projects that just show what's possible today, including these two that I showed earlier in the presentation. And then maybe to last slide, to some active research. Interesting new formats are always popping up, like one of them being MaterialX that we also heard about a bit today, which is interesting because it kind of promises to be a container for better material interoperability. And it can already be referenced and embedded in USD. We can do that in glTF, even if it's not like fully ratified and specified yet. And we have some interesting prototypes for turning Unity or Blender material graphs into MaterialX and kind of keeping that all the way through glTF and going into USD. Now, there's some ecosystem pieces missing. Notably, iOS AR just doesn't support MaterialX yet. So like the full chain isn't really feasible yet, but I hope that will be coming soon at some point. And another interesting thing that popped up, novel rendering methodologies and things like Gaussian splatting, where you can represent a scene in a very nice way. Where we're also doing a lot of like active research on how can we bring this to the web? How can we make kind of the very seamless flow for authoring and editing? And this is something where also glTF and USD both have their kind of custom schemas and extensions for like putting data into them for novel techniques, which I think is interesting in terms of building on top of them as part of ongoing research. Yeah, and with that, thank you. That's the end of the presentation.
Hi, my name is Alexey Medvedev. I am from Meta, and meantime, I'm Kronos chair for 3D Formats Working Group. And today I will talk about our project, internal project for 3D asset interoperability using USD and glTF. What's our goals? Our goals is to preserve glTF, USD, and glTF lossless round trip and lossless quoted here, because the definition requires some additions. And the goal, the final goal for us in general, we want to build like synergetic use of glTF and USD. And the glTF is more designed to be transport format, USD more to be designed outer format. We have a lot of in common, and we still kind of want to preserve this picture. And for us, we want to make sure we are not losing the information that allows to unblock the use cases. And we want to be specific in our project. So that means we want to create the documentation or the workflows that allows us to unblock this interoperability on the scale. So our mission for this first project is to identify features that preventing round tripping between glTF and USD and then generate useful data and recommendation for glTF and USD communities. That means we can expect some changes in the specs in the future, for example, or we expect the dedicated effort that will make it happen. Then another goal for us is to create and distribute mutually agreed test assets. I will cover this a little bit later, and definitely encourage availability and testing the importers, exporters, and the other tooling as well. And so that's our proposal to do this project, and it kind of happens right now. We started this project internally in the Kronos working group, and we picture this as the several phases. We want to discuss the subset of the features we want to interop from the beginning. And today, during the presentations, we explained a lot of technical details that we want to take into account during these discussions. But again, for us, that means it's more like a formal approach. We just want to agree between glTF and USD working groups what exactly we want to retain, what we can move for the later phases, etc., etc. And if for the current understanding, I think that first of all, we'll start with definitely with the core features as geometry, materials, and animations, and plus possible extensions. And for success for us, that will be just agree how much of existing functionality we can round trip. And what does round trip precisely mean? Again, this topic was covered today many times, but the formats are pretty much close by the nature, but still a lot of differences on the way how we structurally present data internally, what exactly should be preserved, because it's still differences between the different features and their functionalities. And the pretty much technical explanation takes some effort. Should we retain this topology for the meshes or not? Should we retain this dynamic conversion or not, etc., etc. So again, we want to be formal, that's incoming. The other possibility for USD and glTF interop, it's just like glTF can be a leaf node for USD. Why not? It can be one of the other possible outcomes. In this case, we'll still preserve the kind of USD and glTF synergy. And we need to define what is the actual success for round tripping. Should we just be able to run validation? And is it enough good or not? Is it look similar in the viewer? Is it good enough or not? As I mentioned, structurally equivalent, is it good or not? It has to be turned, and actually we are actively looking for the inputs from the industry, what the people think about this. Another important topic should be include USDZ in this project. So currently we consider USDZ as zipped USD, and probably the answer will be yes. If it's Apple USDZ flavor, so we don't know. And we are actively looking at the round trip good test suite and test assets. Blender is a good example. The previous presentations are good examples as well. It's still in research, and we will come up with some kind of decisions soon. And that's approximate our scope for this project. So currently we're looking at the core glTF functionality and the base PBR materials. Probably will include the KTX textures and metadata. For the future, we consider MaterialX support, quad subdivision, and physics, interactivity, maybe complex scenes or something else. Your input really welcome here. Each phase mandatory includes the test suite and the actual tool chain that will allow us to execute the tests and provide the readable results. And that's pretty much my short presentation here. Again, it's more like a FYI for the industry. We're working on this. That's a pretty much formal project. We'll get the result document published, and at least on MSF format. And then, yeah, we're definitely looking forward for inputs, and definitely looking forward to collaborate with glTF and USD working groups. Thank you very much.
Thank you, Alexey. Now is time for the Q&A portion of the webinar. We can ask all the presenters to go ahead and turn on all your cameras. I'll turn it over to Patrick to lead the way.
Cool. Thanks a lot, Jeff. And Alexey, thank you for that last presentation. I think great example of showing all the ways that USD and glTF are trying to work together. Just going to give a virtual round of applause for all the presenters and a large group of participants who have stayed with us this entire time. I'm going to try to go through as many questions as we can. We have about 12 minutes left. So going back to Guido's intro talk, Ryan asked about the customized shaders or custom shaders in USD, and it adds a lot of complexity. And if we could expand on the current state of MaterialX and the scope of the work there. Henrik, is that a good one for you?
Yeah, so I'm guessing the question was probably asked before my portion of the talk, though I didn't go into too much depth on MaterialX, but MaterialX in itself is quite mature. It was open source now 6 years ago, and it's in a lot of community uptake. So MaterialX in itself, I would say, is quite mature, and its maturity within USD is growing rapidly. As of earlier this year, MaterialX gets built by default as you build USD, and more studios are using USD and MaterialX in conjunction, and we see more software vendors supporting that, including Autodesk, but also Adobe, and I think Apple also voiced their support of USD and MaterialX as a combination for their upcoming products as well. So it's definitely growing in maturity and how well you can use MaterialX within USD.
Great. Any other presenters want to chime in on that? Okay. So next up, also during Guido's talk, Alberto was asking about if we would add neural meshes to USD and glTF, and also Gaussian splatting techniques. I know, Felix, you touched a little bit on Gaussian splatting. Would you want to share your perspective on that?
Sure. I mean, it's always interesting to see kind of new formats emerging, and there may be, where I think there are cases where they are actually better than kind of traditional meshes for representing certain types of surfaces, like fabrics or vegetation or very thin things and transparent things. And so it's something that we're looking at least for especially these kinds of cases, right? For specific products and e-commerce on like, hey, this is an interesting way that may bridge the gap between photographs and what we can do with traditional meshes right now. And yeah, there's lots of interesting challenges. Like right now, these files are giant in the hundreds of megabytes. There's interesting compression techniques actually coming from the formats that have been developed for glTF, like how Draco and Meshopt and KTX2 and so on compress stuff that look promising to be applicable to these like Gaussian splatting point clouds in some ways. And so I think that's something that's very rapidly evolving, and I hope in a couple of weeks we have more insight into like full pipelines back to the web and showing things, and ideally in a compressed stage to see how feasible is it actually for like real world usage.
Yeah, I like that, Felix. And if I could add a question here too, so I'm curious, and maybe Eric, if you wanted to start with your perspective on, we're pushing innovation, and then we're also creating standards, and how fast do you start to standardize, the things that are coming down the pipe?
Yeah, I was interested to see like at the around SIGGRAPH, someone actually released like how there's Turbo Squid and there's these other model sites, for mesh models. Someone started a Nerf model site of all things, which seems a bit premature to me, I have to admit. We haven't really locked into any standard format as far as I know. But yeah, I'm interested to sort of see how that evolves. Can we yeah, like sort of what Felix was saying, there's really cool things going on with nerfs, and this the 3D, this Gaussian splatting stuff is very cool. And I think us older folks kind of like the Gaussian splatting because there's not any neural in there. But and also they just have a different kind of a flavor. Like the Gaussian splats are more sort of traditional pipeline-ish kind of thing, although you have to do a lot of sorting for transparency, and nerfs are more maybe ray tracy. So anyway, it'll be interesting to see. I think we're all kind of converging onto something that's sort of voxel-like and sort of view dependent, like locally, and capturing material kinds of capabilities and so on. So yeah, I'm pretty excited to actually see how this evolves, because I don't think we're anywhere near a place where we can all go, yeah, that's definitely the format. I mean, polygons are not, well, polygons can be pretty darn hard too, as we've seen. There's like, how many variants of polygons within USD. But here I don't think we're quite at the point where we can just lock in and say, yep, this is the one.
Yeah, and to this question of kind of standardization versus experimentation, I think at least our strategy has come to a point where we always try to build on top of open formats in a way that like already looks similar to what it would be if it would be an open standard. Like basically for these Gaussian splatting experiments, of course we're putting stuff into a glTF extension, and of course we're giving it a name, and of course we have to decide on some way of doing this. So if it's the right way, I don't know, but we can put it out, and there can be discussion on a level where you already have something working. You're discussing about like practical concerns, and then everything can still change and move towards like what is an actual agreed upon nice way of doing it. But I think it's good to, like, in some cases, to move very fast and kind of spearhead. Here's one way, if we think this through, how everything could work, which then can inform kind of the slower but super important discussions on putting everything into stone and making sure like this is set for years to come. And so I think there's an interesting balance of like people just experimenting with stuff and people just thinking on this on a theoretical level that is both super important to kind of inform each other and like advance kind of the state of the art there.
Yeah, I agree. So I want to step back and maybe do an even more basic question that Thomas asked, and he said, well, round tripping meshes not just downgrade everything to triangle meshes. So I believe this would be, going back and forth between USD, glTF back to USD, because USD has quads, and n-gons and subdivision surfaces. Alexey, would you want to go first on this?
Yeah, I'll take this over. Yes, I think we can expect the at least considerations about this. It's the one of the most discussed point, should we support quads or subdiv in glTF? And I think we can expect that the interop will be a driver for us to consider those features in glTF. So yes, I will say that's one of the major point for us, for interop project in general.
Definitely. And then Felix or Eric, from a user perspective, anything you would want to add?
Sure. I mean, what we're seeing is that for a lot of like end users, so to speak, like end user creators that are bringing like models through a pipeline and in front of people's eyes, it doesn't matter as much. Like from as long as the visual appearance of something stays true to like what an artist intended to be, it doesn't really matter if it's quads or tris at this point. It's definitely a question for like pipelines and interoperability, and like how long do you stay in either an internal format of some software like Blender that has like multitudes of things to work with, or can you stay in USD for a little bit longer, and at which point do you drop that because you go to GPU land and efficiency and whatever? And at least what we found was this kind of USD sitting around a long chain of glTF, it works quite well. Like in the end, it doesn't matter if the model is still quads or is triangles or whatever, as long as it's true to what you want to present and what you want to show.
Yeah, I don't have much to add. I mean, really, like Felix and so on are talking about it, sort of authoring versus viewing. You know, at viewing, triangles are pretty much fine for most everything, but with some weird exceptions. But you know, but when you're authoring, obviously, you want to try to keep that original data around. It's like Microsoft Word versus PDF or something. You know, it's you can edit a PDF, but it's not the fun way to do it. No offense, Adobe.
All right, so I love this next question from Kev. Is anyone working on embedding glTF with OpenUSD? Basically having glTF nodes within a USD scene? Henrik?
Yeah, so unfortunately Guido couldn't join us for the Q&A here, but I believe that's something that Adobe has talked about, and NVIDIA as well. So I don't know if Eric, if you have any insights there on how far along that work might be, but yeah, I've heard several companies looking into that particular combination of using glTF as basically leaf nodes within a USD graph. Eric, do you have any?
No, it's the first I ever even thought of the concept. So somebody probably does, but it's not for sure.
I think as part of Omniverse, there's a desire to be able to kind of aggregate, multiple different models, of course, and glTF being one of the formats that you could basically just hang within your USD graph. But I think Guido would have had more to add that from the Adobe side also.
Yeah, and Henrik, if I may chime in myself, I think it could be a very cool long-term opportunity, right? So that glTF representing the kind of the core geometry and USD doing all of the very complex composition. I think it's a very cool thing to consider. So. Henrik, one more question coming your way from Eric, who asks at the timescale for the public release of the OpenPDR spec. Yeah,
we were pretty optimistic that we announced it as SIGGRAPH, but it's any day now. So fingers crossed it will be public in the coming week here. So we're still going through some of the feedback and just making sure that we incorporate everything that has come in between the SIGGRAPH and now. But I think we're aiming for that in any day now. So keep your eyes open.
Great. And then I see in the Q&A window, I'm just not sure if all participants can see it, but Charles from Adobe chimed in and says they're working on open sourcing a file format plugin for USD, which includes a glTF plugin. So I think that's great news and maybe part of a longer term story for glTF nodes in USD. Okay, so I see I'm in Eastern time zone and it is 3:30. So I'd like to ask our host if we should be wrapping up right now.
Wonderful. Thank you, gentlemen, for a wonderful webinar. We appreciate all the time and effort you put in getting this together. As you leave the webinar, please take a moment to fill out the survey that pops up. Your feedback is important to help us improve these presentations. And please let us know if there are any other metaverse topics you may be interested in. Thank you for joining us and have a great day.